Video, I want to cover just review again the first law analysis on the throttling device. So if you recall, we just are starting into refrigeration cycles in this chapter. Just to review real quick, basic refrigeration cycle is saturated vapor going into saturated vapor refrigerant going into a compressor, getting compressed to a high pressure superheated vapor, going into a condenser, rejecting heat to the environment or to the environment, coming out as a saturated liquid, going through a throttling device, getting throttled down to a lower pressure, coming out as a saturated mixture, and then going into an evaporator and coming out as a superheated vapor. So again, on the TS diagram, as shown in the prior duration curve, we have lower pressure line, the upper pressure line. The ideal cycle goes state 1 to state 2, isentropic compression, state 2 to state 3, constant pressure heat rejection, state 3 to state 4, expansion, state 4 to state 1, heat absorption. Let's look at the throttling device. If you remember, a throttling device is a device that you have refrigerant. We'll call this state 3, since this is a that's the part of that's the state, that's what we call the state going into the refrigerant at point 3 going into the evaporator into the expansion valve, sorry, coming out at point 4. So if I do a first law analysis on this, right, a first law analysis, E in minus E out equals delta E system, where delta E system is 0 because this is a steady flow device. Energy in equals energy out. Now, this is going to be a steady flow device, and if we look at energy by heat mass and work in equals energy by heat mass and work out, well, if we assume this to be small enough that there's no noticeable heat loss, and this is obviously not producing or consuming any work, so we end up with mass flow rate times enthalpy in, right? And we're going to go ahead and ignore the kinetic and potential energy changes of the refrigerant across the device. So we have mass flow rate times enthalpy in equals mass flow rate times enthalpy out, where again the mass flow rates can cancel out. And so we end up with H3, or the H going in, equaling the H going out, resulting in the fact that my throttling device is an isenthalpic device. So I just wanted to go over that real quick to make sure that we recalled that knowledge when we're analyzing these refrigeration cycles.